countless quantities exist around us and we divide them into two categories. Number one is physical quantity and number two is non-physical quantity. What is the basic difference between a physical quantity and a non-physical quantity? See, all those quantities which we can measure using some instrument and which fits into the laws of physics are called physical quantities. Okay? Like length, mass, time, volume, temperature, density, they are countless. Okay, so all those quantities which can be measured and which fits into the laws of physics are known as physical quantities. Like I can measure length 2 meter, 10 meter, 15 meter, 20 meter. Similarly, mass 1 pound, 10 pound, 100 kilogram, 1 ton, 100 quintal, etc. Okay, volume 10 meter cube, 20 meter cube, 30 centimeter cube. Clear? So all these quantities can be measured, and for this reason they falls under the category of physical quantities. At the same time, there are few quantities which cannot be measured. Okay, like emotions. You cannot measure emotions. You cannot measure how beautiful someone is, right? You cannot measure how sad someone is, how ugly someone is, how rude someone is. Clear? So all those quantities which we cannot measure and which does not fits into the laws of physics are known as non-physical quantities. Example, beauty, rudeness, ugliness, emotions, all kind of emotions. Okay, all of these quantities falls under the category of non-physical quantities. Clear? Non-physical quantities completely depends upon our perception. For me, someone might be the most beautiful person, but for some other person, he or she may not seem as beautiful, right? Now, the physical quantities are further divided into three categories, namely fundamental quantities, which are 7 in numbers, supplementary quantities, which are 2 in numbers, and derived quantities, which are countless. In fact, all the physical quantities, apart from these 9, that is 7 of the fundamental quantities and 2 of the supplementary physical quantities, all the remaining physical quantities falls under the category of derived physical quantities. Clear? Now, talking about fundamental quantities, they are 7 in number, starting from mass, the unit of which is kilogram. Of course, we are talking in SI system of units. We will have a brief look over other system of units also, like CGS, MKS, FPS, and of course the most important SI system. Okay, right now we are talking in SI system. Clear? Mass, the unit of mass in SI system is kilogram, which is symbolized by the letters K and G in small. The unit of length in SI system is meter, okay, and is symbolized by M in small. The unit of time in SI system is second and is symbolized by the letter S again in small. The unit of thermodynamic temperature is Kelvin and is symbolized by the letter K in capital. Why capital? Just answer me, why capital? The unit of electric current, ampere, which is symbolized by the letter A in capital. The unit of luminous intensity is candela, which is symbolized by the letters C and D in small. And the unit of amount of substance is mole, which is symbolized by MOL in small. Okay, see, the symbol of the units of all the fundamental quantities except thermodynamic temperature and electric current. The units of all the remaining fundamental quantities are in small letters, but the unit of these two are in capital letters. Why? Because these also stands for the name of some person, of the scientist. For this reason, both K and A are in capital. Clear? K stands for Kelvin, which is also the name of a scientist, and A stands for ampere, again, which is also the name of a scientist. Clear? Of course, we are talking in SI system. Okay, there are several other system of units also, about which we will talk after a few moments. Now, coming to supplementary quantities. Supplementary quantities are 2 in numbers, namely plane angle. See, you all guys are very familiar with plane angle because all of you have dealt with plane angle till class 10th. Okay, let me explain plane angle for those who do not know. Suppose, why it is called plane angle? It is called plane angle because it is formed in a plane. It is in 2 dimensions, right? In a plane, we call, like in a triangle, angle bit formed between any 2 sides. Plane angle is formed between 2 lines, like between my 2 hands. This angle is a plane angle. Why? Because this angle is lying in this plane. Clear? It is in 2 dimensions. Suppose there is a arc of length AB subtending an angle theta, okay, and this is the radius r. Then theta, the value of plane angle theta, can be given by length of the arc, that is AB, length of the arc upon R. With this relation, we can get the plane angle. See, we have been expressing plane angle in degrees, right? 20 degree, 60 degree, 90 degree, 120 degree. But always keep in mind that degree is not the SI unit of plane angle. Okay, the SI unit of plane angle, is radians. Don't think that I am explaining about derived quantities. I will come to it later. I am talking about plane angle. I am explaining about plane angle. Okay. The SI unit of plane angle is radian, and there is a relationship between degrees and plane angle. Okay. 180 degrees is equals to pi radian. Okay. 180 degrees is equals to pi radian. Right? 180 degrees is equals to pi radian. That if 180 degrees is equals to pi radian, radian is the SI unit of plane angle, which is symbolized by the letters R, A and D in small. Okay, we call it rad, pi rad. Okay, so 2 pi radian will be equals to 360 degree. Clear? Pi by 2 radian will be equals to 90 degree, and so on. Clear? So this was all about plane angle. If we shift from 2 dimension to 3 dimension, we will get solid angle instead of plane angle, right? Here the angle was subtended by an arc, right, which is 2-dimensional thing, 2-dimensional shape. Clear? Now here the arc will be replaced by what? A surface, right? Like a semicircular arc. Take a semicircular arc. It will subtend an angle of 180 degree at the center. Clear? This semicircular arc, it is in 2 dimensions. Now change it into 3 dimension. Okay, this semicircular arc will convert into what? A hemispherical surface. Imagine half of a ball, a hemispherical surface, and that hemispherical surface will subtend a solid angle at its center. This angle will be solid. Clear? I know you guys are good in imagining things. Okay, now solid angle has a unit of steradians. Steradian. Okay, steradian, and it is symbolized by SR. Now, just like plane angle has a formula, we have a formula for solid angle too, to calculate solid angle subtended at any point. Okay, and that is given by d theta is equals to area upon what? Square of the radius. Okay, see here, in case of a plane angle, we have taken the example of a semicircular arc. So it has a length, but if we replace this arc, semicircular arc, with a hemispherical surface, we will have an area, right? The area of the hemisphere. That area will subtend an angle, will subtend a solid angle. Okay, and that solid angle theta, forget this d, you will learn about it in differentiation and integration. So theta is given by a upon r square, and a is the area that is subtending a solid angle theta at a point. So if an area, we are talking about an area, see, just like 2 pi radians is equals to 360 degree. Okay, right? 360 degree is the angle subtended by the circumference of a circle, the entire circular arc at the center of the circle, right? In the same way, in case of solid angle, the entire spherical surface subtends an angle of 4 pi steradian. Okay, 4 pi steradian. Okay, the entire spherical surface subtends an angle at the center that is equals to 4 pi steradians. 4 pi steradian. Clear? Now coming to derived quantities. Why these quantities are known as derived quantities? See, there is a simple reason behind it. Okay, the units of all the derived quantities, of course, derived quantities are countless in numbers. Okay, they are infinite in numbers. You cannot count the number of derived quantities. Clear? The unit of all the derived quantities can be obtained as a combination of one or more of the units of the fundamental quantities. Clear? For this reason, they are known as derived quantities. Let me give you an example. there are infinite number of numbers. Okay, 0, 1, 2, 3, 4, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, so on, so on, so on, right? Did you notice that apart from these 10 numbers from 0 to 9, all the other numbers are just a combination of these numbers, okay, in various possible orders, either with or without repetition. Like when I say 232, it's just a combination of 2, 2 and 1, 3. All the digits are coming from the numbers from 0 to 9, right? Similarly, when I say 2356, all the digits are coming from these numbers from 0 to 9, right? So we can take these 10 numbers as fundamental numbers and all the remaining numbers as derived number, because they are derived from these 10 numbers. I just said it as an example for you guys to understand the relationship between the fundamental and derived quantities easily. Okay. So all the quantities other than these 7 fundamental quantities and these 2 supplementary quantities falls under the category of derived quantities. Like say density is a derived quantity, right? Then comes, there are countless number of derived quantities. All physical quantities that you can imagine apart from these 9 will be derived quantity. Velocity, acceleration, right? And various other. Okay, let's try to find out the unit. What I just told you is that the units of derived physical quantities can easily be obtained from the units of fundamental physical quantities, right? How? There is one condition. Okay, you need to remember at least one formula containing the derived quantity, the unit of which you are intended to obtain. Okay, for example, we know the formula for density, that is mass upon volume. Of course, I'm talking about mass density. There are several other types of densities also. You will encounter them in your subsequent chapters. No need to mention here. Okay, so we know that mass is a what? Fundamental physical quantity. Okay, so we will write kilogram, the unit of mass, upon volume. Volume means SI unit is meter cube, right? That is cube of length. Length is also a fundamental physical quantity. So the unit of density will be kilogram per meter cube. Similarly, velocity is what? Displacement upon time. Displacement is a kind of length. Displacement is a length. Unit meter upon time. Time, again a fundamental physical quantity. Unit second. We are talking in SI terms, SI system. Okay, I am repeating again and again, we are talking in SI system. Now acceleration is rate of change of velocity, change in velocity upon time taken, right? So since velocity has unit meter per second, so change in velocity too will have unit meter per second. Meter per second upon time second, that is meter per second square. Similarly, all the units of all other derived physical quantities can be obtained using the units of fundamental physical quantities, as long as you know at least one formula containing that derived quantity, the unit of which you are intended to obtain. Okay, let me give you a few more examples of it. Remember, you can find the unit of any of the derived physical quantities from the units of the 7 fundamental physical quantities, provided you have at least one formula containing that very derived physical quantity, the unit of which you are intended to find. Okay, so area, we know the unit of area is meter square. Why? Because we know the formula of area will be a length multiplied with another length, right? Clear? So meter into meter will be meter square meter. Similarly, acceleration, we know the formula of acceleration is what? Change in velocity upon change in time. Okay, change in velocity upon time. So We know the unit of velocity is what? Meter per second. Meter per second upon second, time second. That is, the unit will be meter per second square. Momentum. Momentum is equals to what? Mass into velocity, right? The unit of mass, kilogram. The unit of velocity, meter per second, kilogram meter per second. Okay, this will be the unit of momentum. The unit of kinetic energy, the formula of kinetic energy is half mv square. Okay, numbers has no unit. Okay, so ignore half because we are only considering the units. Clear? Mass unit is kilogram, velocity square, that means meter square per second square. Velocity, the unit of velocity is meter per second. The unit of velocity is meter per second, and the square of it will be meter square per second square. So the unit of kinetic energy will be kilogram meter square per second square. You can write it in a better way as kilogram meter square per second square. Clear? Now stress, the formula of stress is what? Force upon area. See, you might be encountering many of these quantities for the first time. Okay, it is understood. You will learn about these things, and these and many more to come in the same video. While talking about dimensions, I will give you many examples, and there will be many terms that you will be hearing of for the first time. Okay, so it is understood. Time will come and you will study about those things in detail. Okay, for now, what is important for you guys to know, to remember, is the formula. Just concentrate on the formula. Okay, in your subsequent chapters, you will study about all these terms in detail. So the formula for stress is force upon area. We have force is equals to mass times acceleration from Newton's second law. Okay, you will also learn it later in mechanics. Force is mass times acceleration upon area. The unit of area is meter square. This m stands for mass. Okay, not meter. Remember that. Mass, the unit of mass is kilogram. The unit of acceleration is meter per second square upon meter square. Okay, so it will be kilogram meter per second square into meter square. Meter, that is kilogram per meter second square. This will be the unit of stress. Is it okay? Let me see. Force upon area. Force is mass times the acceleration, kilogram meter per second square. Okay, kilogram upon second square into meter. Okay, it's okay. Frequency is 1 by time. It will be 1 upon second, that is second to the power minus 1. This will be the unit of frequency. Impulse is force into time. Okay, force into time. The unit of force is what? Let's write it in terms of formula. Mass into acceleration is force into time, right? Mass, the unit of mass is kilogram, and the unit of acceleration is meter per second square into time, that is second. We will get the unit of impulse as kilogram meter per second. This is meter. Now coming to strain. Strain is the ratio of change in length and original length. Okay, you will study strain in properties of solids. Okay, strain is the ratio of change in length and original length. That is, strain is equals to delta L upon L. Delta L is change in length. We will express it in meters. Length is again a length, so we will express it in meter. Meter cancel out, so strain has no unit. We will talk about many more physical quantities while discussing about dimensions, so have patience. Okay, we will talk about many more physical quantities while discussing about dimensions, so have patience. Okay, now let's talk about a few system of units like CGS, MKS, FPS, and of course the most important, that is SI system of units. Okay. CGS, as the name suggests, it stands for centimeter gram second. Clear? Obviously, it has centimeter as the unit of length, gram as the unit of mass, and second as the unit of time. Similarly, there is FPS. It has feet as the unit of length, pound as the unit of mass, and second as the unit of time. Similarly, we have MKS system. which is meter as the unit of length, Kelvin as, sorry, meter, kilogram as the unit of mass, Kelvin is the unit of what? Temperature. Okay, and second as the unit of time. Clear? So of course, each of these system of units have well-defined units for the remaining four fundamental quantities too, but we normally do not talk about that. Okay, when I say a system of unit, what I actually mean, see, each of the system of units has its own set of units for each of the fundamental quantities, right? Clear? And hence for the derived quantities too, right? Each system of units has its own set of units for each of the fundamental quantities and hence for the derived quantities. Clear? And they differ, one system of unit differ from other system of units to small or a less extent in some way. So this is the difference between these system of unit. Similarly, we have SI system, which has, again, it is quite similar to MKS system, but there is a difference. You can say that SI system is a superset of MKS. Okay, and it is or you may also say that SI is the modern adoption of MKS system. There is difference here, you will find it similar, but there is a difference. In SI system, length is meter, is the unit of length is meter, unit of mass is kilogram, and the unit of time is second, of course. Okay, this is the most important. Remember that in this chapter and in all the chapters to come, we will be mainly dealing with SI system of unit. It is the most important and most widely adopted system of units. Clear? It is an SI is an abbreviated, SI is the abbreviation of the French words Système International. It's not important to remember. Okay, what is important is that you should remember the English of SI is International System of Units. Clear? The English of SI is International System of Unit. This is the abbreviation of French words in Système International. There is something else also, but no need to remember this. It may seem that the MKS system of unit and SI system of unit are same, but there is a difference. Okay, here you cannot, you won't be able to notice any difference between MKS and SI system here, but there is a difference. SI is a superset of MKS, right? It has some extra characteristics too, talking about which is beyond the scope of this video.